So how many people score between 0 and 20? It's 22. How many score between 20 and 40?
50.
Well, 40, you're now at 72, right? So if you were at 22, then how many people were in the middle? 50, just as Lucas said. Everybody got that?
Yep.
You fill in the charts?
Yep.
From 40 to 60, well, we're going from 72 up to
138.
138. So it's 66?
Yeah.
66. And then from 60 to 80, now you should just be able to subtract all the other numbers from 200, but it's from 138 to 180, so it's 42. And so now check your math. If you add all those answers across that chart, what should that add up to?
200.
200, does it? Did we do it right?
Yep.
Yeah. B, 40% of the students fail. Find the pass mark. Well, it's kind of like what we just said. What's 40% of 200?
80.
That would be 80. So 80 people fail, so you trace that over. That means the pass mark is
42.
42. Okay, you see how you can answer all sorts of questions about this. So any percentile they could ask. All right? So if they ask, what's the 95th percentile? Well, what are you looking for if you're looking for the 95th percentile?
Score at 190.
Well, you would and the easy thing is to take that percent, 0.95, multiply by how many people took the test. In this, it's easy because it's 200. It's an easy, mental math thing. It might not be. It might be 40. It might be 380 people, whatever. Multiply the total number times the percentile, and it's that value in the frequency that you're going to be looking for. So in this instance, 95% of 200 is 180. So you'd go to 180, you trace over, and that score is 80, right?
If you like multiply the number and you get a decimal, do you round up or round down, or good at that point? Like you said, 308 times 495.
Well, they're gonna ask. What you're gonna make sure you understand with IB questions is there shouldn't be any guess to it.
Okay.
It should try to, like you notice every one of these, like when we were doing that chart, it crossed right at, it was easy to figure out, right? My questions always weren't because I didn't design the question. So the short answer is if you get a decimal, check your work, you're probably doing something wrong. Okay? So it should come out to be probably one of the data, even like larger data values, right? Okay. This is a side note I'm just thinking about as I say this. You're going to need to remind me of this. I was told at a meeting a couple months ago that graph paper is different now. Okay? This type of graph paper is the way the graph paper has been forever. It's 2 millimeter graph paper is what this is. So that every one of these big boxes is a centimeter. Okay? See how there's 5 little boxes and then a big box? That's what they've used forever. I think it's similar dimensions, but it looks completely different. And you actually have graph paper given to you on exam day to use on some questions. Usually there's maybe one question in either, over the entire 2 days of testing, there's only one graph paper question where you have to actually draw a graph, usually, okay? But remind me that I need to get you a piece to look at before then. So for next time, I'll bring it in. If somebody can, I forget because everything's going on. We're also going to have a meeting. I may just come, Hoffman said I'd come to her classes. I don't know how I'm going to do it yet, but you know how when you took tests last year, you had the glide paper? It's completely different now. It's like booklets, okay, for all your tests. I'm talking every subject, all right? So the station, what they call the testing stationery is completely changed. So we're going to have to get together and I'll show you how that, so you can get comfortable with it prior to your tests in May, all right? All right, everybody go to question 3 here, cumulative frequency. So guarantee you will see cumulative frequency. All right, we're going to skip around here because we're going to skip just to that sort of questions. And so we're going to go over the probability, come back to that. Probably could go over to the page that says non-calculator. It's another cumulative frequency. See that one? All right, so now that we've looked at the other one, let's take and do this one by yourself. And take 1 minute and try to answer A and B. Okay? And then we can see if you know how to do that. This was on your test last week, wasn't it?
Yeah.
Okay, I just realized that. So, all right, so we don't necessarily need to do it by ourselves. What's the answer to A?
How do you get 4 marks for B though?
What?
How do you show 4 marks of work on B?
Yeah,
Well,
right.
can you just, we need,
We're getting 2 points for each answer.
Yeah, you're gonna.
Here's what I would do to show work, okay? It's the middle 50%, right?
we just draw.
So I'm gonna circle, because they see your graph. I mean, your test booklet has this and then has a block to answer it. I'm gonna circle 200, I'm gonna circle 600, right? I'm gonna draw lines till it hits the curve. I'm gonna make sure they know what I'm doing just in case I write down the wrong answer. 9 times out of 10, Dimitri, you're getting full credit for just your answer
Okay.
on a question such as this, okay? But just to make sure that I'm gonna draw down, and I'm gonna draw down, because what if I mess up and didn't realize that A had to be less than B, and I wrote A equals 75 and B equals 55? Well, by showing this work, I'll probably get 3 out of 4.
Okay.
But now I've ensured, and I might even write A right there, and might write B right there, so that I know A equals 55, B equals 75. Got that? So anything you can draw on there like that, that's a way of showing work. Does everybody understand where we got 200 and 600 from? Okay, because the middle 50 is just, you know, you're cutting it into fourths. 2, 4, 6, 8, right? Okay. Okay, I think that's all I have on here for that sort of thing, and we'll probably see some of it as we go on other stuff in the probability questions. All right, so let's go back over to the first page of questions, or I mean, let's go to the second page, number 5, and we're going to go through and look at a bunch of probability stuff. You notice there's a reason there's more probability questions here, is because there's been more probability questions on old exams. Okay. Let's stop before we get to that. Let's everybody get their calculator out. All right. I know you guys know how to do how to make lists and stats, because in the stat menu you had to do it for your IA. We did it on the last year in the IA, but let's just work with that real quick. Let's say we have a list of 6 numbers. Okay, so I just made 6 random numbers. We're going to put that into a list so we can look at the statistics on those numbers. Now, usually you would have probably 20 numbers to look at, right? In this instance, we're going to say 6. So you go stat, and you're going to go edit, okay? And the angle on this is no good. So usually you want to do this one, right? So you put them in. Okay? And then you're going to go, quit out of there, you're going to go stat, calculate, which is the middle menu, 1 variable stats, the very top one. Okay? And the default's list 1.
Dang.
What?
Does you everything.
Everything's there. Okay? What's X bar at the top right there?
Mean.
Average.
Mean. It's the average. Go ahead, Sarah.
When I do the 1 variable stats, it comes up with a list, and it says like list L1, frequency list L2, and then calculate. It doesn't automatically
You have
do
to
that.
clear the list too, because it thinks you have numbers in that one.
Well, I had numbers in the list
And
too,
then
it
it
still did it for me.
Okay, never
Because
mind.
it's 1.
Well, although if you don't have numbers in list 2 and it says L2 under,
So you just hit clear and then it's,
Yeah.
okay.
Yeah. And that's the
And
new
what's
operating
that?
system,
What
which
is
is what it has.
Absolutely.
Why would it give the frequency list there? What does that mean?
because it's how many times each of those numbers occur.
Correct.
Wait, I have Sarah's problem too, but I have numbers in my second list. What do I
You
do?
have to press clear.
Do we use our calculators, or they supply to us on test?
They're supplied to you.
Big suitcase full.
They're cleared out.
Would it be the new system?
It's the new system.
Thank you.
Was there an even newer system? Because I saw like someone with a calculator that had like.
I don't know.
It says
I'm gonna need some help doing that. We're gonna have to reprogram all of them.
Yay.
What?
It won't let me get that.
Did you go to stat or
Okay, let me go back to this real quick. The whole frequency list is if you use that if you have group data,
I did, but
you had to delete list two?
okay? Or if all you have is a frequency chart, sorry. If you have a frequency chart, you use the frequency list because it can do mean and all for you based on because it's how many you have. Here's one variable stats. This is your mean. This is the sum of all your values, and this is the sum of your values squared. Those are really useless to you. Okay, these are two different standard deviations. You always use this one, which is sigma. Okay, it's the lowercase sigma, right?
That's
Yeah.
the what?
Isn't it? Sigma.
Yeah.
Okay, I haven't looked at it in a while, so I'm gonna verify with the
Lowercase sigma.
theoretical mathematician in the corner over here.
Is 1450 the variance?
No. 1450 is the sum of the data values squared. If you were doing hand calculations for standard deviation, then this would be important to you. Since you're not, you can ignore it.
What's the last thing? The sigma x?
Okay, this is actually a sample standard deviation. This is a population standard deviation.
Yeah.
This is the one that IB wants you to use.
Okay.
Don't ask me why, I don't have a clue.
Okay.
And I don't know stats well enough to know why the difference in the calculations. There's two different formulas you use to get each of these. They want the bottom one. Always use the bottom one. Don't use the S. Use the little. It's the lowercase sigma.
The bottom
It's like
one?
a circle with a little tail on it.
The bottom one is the population one?
Yeah,
Okay.
and that's what they always want you to use.
And
Yeah.
we'll always have
Now for like the ones, like problems that ask for like the quartiles and things, will it be non-calculator questions? Cause like this gives it to you.
It would only be non-calculator if it was something like that frequency curve thing. Okay, or something you could do quickly and easily. Yes, now if you scroll down, this gives you all the data you need to do a box and whisker. Sarah,
What's N?
N is the number of data values you have. So we put 6 in, that's N. Now, this should be pretty self-explanatory. You have your minimum, you have your quartile 1, your median, which is quartile 2, right? Your quartile 3, and then your maximum, which is quartile 4, right? So you have, this is your line, this is the edges of your box, this is your 2 whiskers, or box and whisker, right? And if you're ever doing a box and whisker, you need to set up a number line, x-axis underneath it, and label all 5 points on that number line, besides just labeling them on the box. That's just good practice to
Do we
do.
need to do the, just standard values, like 1, 2, 3, 4, 5, or just the important ones?
You can just do the important ones. Okay. Or you can have some sort of scale written and then label the important ones up above. There's a couple different things. All right. Your calculator will actually make a box and whisker for you. If you go to stat plot, like you did when you did scatter, you know what I'm talking about? The 5th one down there at the bottom is a box and whisker. The 4th one is too, but that doesn't connect outliers. It's some sort of weird box and whisker, I don't know. But if you click this one, now you have a box and whisker, and if you hit zoom stat like you did with your scatter plots, what's it doing? Why does it say invalid dimensions?
What button?
I shouldn't have a frequency list.
You're the RAM. Yeah. You're the RAM.
Yeah, I know, whatever.
Put frequency 1. How do you clear the roll?
Just delete it.
Second plus
Delete the
712.
whole calculator.
Second plus 712 empties your RAM.
Yeah, you did that really fast.
Second plus 712. It's just, you memorize that. Walk you through it.
Yeah, you did it? Yeah.
What was it?
7 months to go. Okay, you will type it in real fast.
It's on your program. All right, so there's your box and whisker, and if you hit trace, then it'll just show you the 5 points, which is the same thing that's in your one variable stats.
What, how'd you?
I did the box and whisker and stat plot, and then I hit zoom stat.
Then how do you find these?
Stat plot.
And then what did you hit after zoom
Hit
plot?
Trace,
And then zoom stat.
hit trace, and then you can arrow back and forth.
Which blocks and whiskers do we use? The one on the left or the one on the right?
The one in the middle.
The fifth one.
Okay.
Yeah, not the one that's connected, not the one.
We
Well,
get
you
to
can
that.
graph.
You have to keep on going to the right.
Okay.
Oh, I
there
think
you
I
go.
turned it on. Yeah, I think I turned it on.
So anyway, that's box and whisker. That's
That's pretty
using the
good.
calculator with one variable
The
stats.
zoom stat.
Look at that.
Alright, just press this way, it's your next graph.
It's there.
Now, just to reiterate, if you did have frequencies, if this was X and this was frequency of X, okay? You don't need to enter 2 3s and 4 8s and 7 12s and 5 14s, and see what I'm saying? You could actually just go to L2
Yeah.
And then you put them as like a different.
and put them in and list 2 as your frequencies. And then yours is going to look a little different than this, but you can put L1, L2 with the old system, or you can actually, your new system has it tells you frequency list, right? And tells you what to do.
Yeah.
So this is your mean of the frequencies, because now I have 2 3s, 4 8s, and 7 12s, and so this is my new mean, and all the other data.
Where is this comma?
Thomas next to the parentheses.
Above 7.
Oh, there you
Yeah, the new operating system actually says X list, and you're going to say list 1, frequency list, list 2, and then it does it. It's not so hidden on the commands. So again, for this new data collection, this is now my standard deviation. You know, you can see these are all your quartiles and all that. So it's just what you would do if you have frequency chart as opposed to just raw data. Now, let's go ahead and talk about this then. What if we had this? All right, what do we have now?
You have a histogram.
Yeah, we have grouped data, right? We could create a histogram.
Can you do it with this?
Depends on what it is, because it's what?
Can you do a histogram on here?
Yeah, but you don't ever want to, because it doesn't let you pick your width of your intervals. It creates it for you, and sometimes it can create like really odd interval stuff. Okay. But what if I asked you what's the mean of that data? Well, you can't give me an exact answer because you don't know what every data point is. You can, however, give me an approximate mean.
Don't you get like the middle of each one?
Right. To find an approximate mean. Okay, which again, what letter do we use for mean?
X.
You could use X bar, but usually, because just so you can use X bar and S sub X for standard deviation, we use sigma. We're going to use mu, okay, for mean. Because that's what you're going to use with normal distributions, right? Okay, so that's what we're going to use here. So the approximate mean, and I guess I don't even know, do they use the little that, or I don't know.
No, they don't.
Yeah.
What?
They don't. They don't in the book at least.
I don't either think so. So basically, we're just going to use this for mean, but approximate mean. What you're going to do is exactly what William was saying, which is use the middle point, okay? You're going to do what we just did with the 2 lists, but you're going to use 2.5, 7.5, 12.5, and 17.5 as the X, and then the frequencies. You see what I'm saying? And that's how you're going to get an approximate mean. Because we don't know if these three are all 4 or if they're all 1, but we know they're in the middle here, and so we're going to approximate them as the midpoint of whatever interval. Now don't be surprised if they give you like this, and these intervals are different widths. This could be a width of 5, and this could be a width of 8, and this could be a width of 12, and this could be a width of 3. You know, like, so it's the midpoint of whatever the interval happens to be. You assign all of these as that value. Okay?
So you find the midpoint times frequency and then divide by
Well, that's to define the mean, yeah. Define the mean, you do that. But if you're finding beyond that, if you want, if it wants to do more stuff, the mean, you're just the midpoint times that plus the midpoint times that plus midpoint times that and divide by total number. Yeah, mean is pretty easy to do. All right, so that's a little more descriptive statistics. Let's go to probability. I pity the people that are watching this later because what I'm doing is not making any sense if you're not here to see it because there's no continuity because I'm all over the place. So, is that actually showing me or just that?
Just the board.
Good.
It sounds interesting.
Audio isn't recorded?
It's a bunch of pencil.
The sound is working or not?
It's connected.
Wait, William, you only have the board?
The board, yeah.
You can learn anything with the board.
We're gonna learn it.
If they can hear me and they can see that,
His face is not going to
Yeah.
Is the audio actually working?
It's connected. I don't know if you loud enough.
Plug in headphones.
well, do you need to move that up here?
I think so.
What does the VU meter say?
Why don't you look at it? Because if you need to move it up, or if I need to be louder, I can be louder.
I can move it up.
But don't you put like the microphone close to it?
Yeah.
Yeah, the microphone.
Check the meter or whatever.
You know the microphone could literally be right in front of him?
Probably.
That's what I do.
So everybody can hear us
No,
right
no,
now.
seriously, like,
Yeah.
Why have like interview style? You just like,
Yeah.
Didn't want to get anyone's face.
Yeah, it's probably better with the lock.
There's a ghost.
Keep it away from Dimitri. That'll
it
be a
picks
good
up
idea.
a lot of sound. It does.
He already has one
So
mic, I think.
Don't like.
Blow on it.
Okay, is that good, Lucas?
Yeah, it's better.
I
Okay.
can hear you breathing.
All right, we're gonna start over. I'm just joking. Okay, let's go to probability now. Okay, so number 5,
That's the 7/8 minus.
probability of A is 1/2, probability of B is 3/4, probability of A or B is 7/8. So how do you calculate the probability of A and B?
You add A and B, and you minus A, U, B.
What?
Yeah.
No, it's you subtract.
Yeah.
No, it's
A plus B.
Yeah, add the first two.
Yeah, it's
And then
you
subtract
add the
the last
first two and then you subtract that, or
3/8.
that's yeah.
That's helpful.
That's
The
here.
more you say yeah, the more pressure.
So 1/2.
Okay, the
plus 3/4.
formula says it's this number is equal to these two minus that, right?
Right.
Yeah.
Well, that means if you solve it back out, then this is also equal to these two minus that. Okay, you can just flip sides of the formula. So 1/2 plus 3/4 minus 7/8, okay, this is,
So
3/8.
yeah. Okay, so now A, this is saying, what's the probability that A happens given that we know that B happens? All right, so again, the formula says to take the intersection of the two, which is now 3/8, the answer we got here, and divide that by the probability of B, which is 3/4. Okay,
3/4.
so this is really means that that answer is 1/2.
And if it was BA,
So
then you
does
just
it
divide by.
doesn't
Oh,
mean it's
3/4
independent.
again. Yeah.
3/8 divided by 3/4.
Wait,
Okay.
it means that it's like,
Oh yeah.
if you're B, you're always A.
Okay. C says, are the events A and B independent? If A and B were independent, so follow me here.
If you have B, then 1/2 of the time you will have A.
No, it means if you're A, you're always B.
No, how?
I think you're talking about two different things.
Yeah.
Right.
What Tirith, what are you talking about? part B here?
Yeah.
Okay, he's not talking about part B, he's looking at part C.
Oh,
Yeah.
okay.
Okay.
Yeah.
Going back to part B, what B is saying is if we know your B, what's the probability you're also A? Well, 1/2.
Same as A, yeah.
Okay.
And so
So it's
then,
independent.
So are the events A and B independent? This has nothing to do with independence, though.
For B.
Okay.
What it does, the probability is the same either
No,
way.
but it's probability if you're B, you're looking.
It does. It does. You're right, but that's not the way I would look at it. I would look at it this way.
It's different.
Are the events A and B independent? They are independent if probability of A times the probability of B equals the probability of A intersection B. That's the formula on your sheet. This is the formula for independent events. Is that the case here? Does 1/2 times 3/4 equal what we
No.
calculated here
Wait,
as
wait.
3/8?
Well, it says here, the probability of A given B equals probability of A. That's the definition of independent events.
Where?
On the sheet.
Okay, I'm not talking about that sheet. I'm talking about your formula sheet.
This is the review sheet.
Yeah, but the formula sheet's the one you're going to have with you in the test.
What do you mean by they're independent?
They don't,
They do not affect.
One doesn't, yeah, one doesn't.
One doesn't affect
like
the other.
if you pass your math test
So
and you
one
pass your
changes the
English
other
test,
one,
but it doesn't matter because they don't
If it's
pass.
independent, it doesn't change the other one.
That's what independence is, yeah. One has no bearing on the other.
So is that one over there independent?
No.
The equal.
It's not?
No.
That one would be independent, right?
Yeah, that would be independent.
Yeah.
What does it say?
Okay.
And the
Maybe, I don't know. I'd have to look at it closer, I don't care.
And the reason is because they equal, or how do you, what's the given reason for your answer?
I don't know, that's made up data.
I think that's right up there.
Because the probability of A doesn't
It's
equal the
not.
probability of A
Well,
given B.
they don't equal that, so I guess.
no, that's not independent. Because there's some they have in common.
Okay.
It's just, this is. Probability isn't something that you want to apply across the board. You want
They're
to each
not.
individual question.
independent.
Okay, let's look at number 7.
That has to be true for it to be independent.
Okay, now we're talking about marbles or balls or jelly beans or any
Did we
other.
ever decide if they were independent or not?
Yes, they're independent.
How do you know that though?
So the formula.
I'm thinking this thing, this is easier
Oh.
to
Wait.
determine.
The reason that's not is because usually you don't even look at additional probability when you're looking at independence.
Yeah. So you're not usually given probability of A.
When you look at, who has the formula sheet with them right now?
I didn't find it, but I did.
You want
So
it?
if they equal each other, they're independent?
No. Hand me that, Wendy.
Oh, that's cool.
When you look at your formula sheet and it says independent events, because this is what you're going to do. You're going to be on the test, you're going to see independent, you're not going to remember, so you look at your formula sheet, right? This is what it says next to it. That independent events only happen if the intersection, A and B, equals the multiplication of A, of the two probabilities. All right? So, in that instance up there, somebody else will go, those would not be independent events because the intersection is not equal to the multiplication of the two. Okay? In this problem, we found the intersection using that formula, right? We used that formula to find 3/8. Now, if you take the two given probabilities and multiply them, do they also equal 3/8? Does 1/2 times 3/4 equal 3/8? Yes.
If you use the other way, will they count as right?
Sure. Okay. So since this equals that, okay, then yes, they are independent.
Okay.
If we had multiplied these two and we got 3/8, but up here we had an answer that was 5/8, then all right, those don't match. It's not independent.
You can just say because it does not follow the equation.
Correct.
Okay.
All right, number 7. Bag contains 10 red balls, 10 green balls, 6 white balls. 2 balls are drawn at random without replacement. Key word in this question is without. what is the probability that they are of different colors? All right. How many different ways could we get different colors here?
Three or six. 3 or 6. Which one's the
6.
Because you can do the opposite.
Yeah. Okay. Because I could have red green, green red, red white, white red, you know, all those.
Do you always consider opposites?
What?
Do you
Order.
always consider opposites?
Yeah, you have to because it's you got 2 different balls you're choosing. Okay. So if I was doing this problem,
You do 1 minus.
I would look at the complement. What's the opposite of having different colors?
Same color.
Same color. How many ways can I have the same color?
6. Well, not 6.
3.
Okay.
3. I can either have 2 whites, 2 reds, or 2 greens.
But you could have different whites.
No,
No
it's,
different.
No, you
it's no
can't.
different. It doesn't matter. 2 whites. I can only have 2 whites.
Okay.
Okay? So what I would do here would be the probability that they're different is 1 minus the probability they're same. So I would say the probability of different equals 1 minus the probability that they're the same. So the probability that they're the same is 10 out of 26 times